Now I have to find the trigonometric ratios of 30 and 60 degree. For that I have to consider an equilateral triangle ABC, as we know that each angle of an equilateral triangle is 60 degree. So I need 60 and 30. This equilateral triangle gives me both 60 as well as 30 degree. So as we know that each angle of an equilateral triangle is 60 degree. Then I have to draw perpendicular AD on base BC. Now I have to show that this triangle ADB and ACD are two congruent triangles. How these triangles are congruent, I will show you. Angle B is equal to angle C, each 60 degree. Angle 1 is equal to angle 2, 90 degree, because as we know that AD is perpendicular on BC. Then AD is common in both the triangles. So these triangles are congruent by RHS. And this implies if these triangles are congruent, then their corresponding parts are equal. That means BD is equal to DC. At the same time, I have to suppose that each side of an equilateral triangle is 2A. So AB is 2A, AC is 2A, and BC is 2A. Then if AC is 2A, AB is 2A, BC is also 2A, then I have already proved that BD is equal to CD. Then this implies BD is the half of BC, and that means BD is A. If BC is 2A, then its half is A. So BD is A. Now I have to apply Pythagoras theorem on this triangle ADB. This is right angle triangle, and I am going to apply Pythagoras theorem on this triangle. As per the Pythagoras theorem, that is hypotenuse square is equal to base square plus perpendicular. This is hypotenuse because opposite side of 90 degree is hypotenuse. So here I am applying the Pythagoras theorem. Hypotenuse square is equal to base square plus perpendicular square. Here AB is the hypotenuse, BD is the base, and AD is the perpendicular. Now apply the values. AB is 2A. So here 2A square is equal to AD I have to find out. Then comes BD, and BD is A. So 2A square becomes 4A square is equal to AD square plus A square. Transpose the A towards the left side. So A square minus A square, 4A square minus A square gives you AD. 4A square minus A square gives you 3A square is equal to AD, and after that it gives me AD is equal to A root 3. Now I have to find the trigonometric ratios of, first of all I have to find the trigonometric ratios of 60 degree. So for that I have to find first trigonometric ratio, and that is sine of 60 degree. As we know that sine is the ratio of perpendicular. Some people have, you have to apply the trick here. Some people have, people means perpendicular and have means hypotenuse. So what is the perpendicular here? This time perpendicular is AD. And what is the hypotenuse? Hypotenuse is AB. Now substitute the values here. AD is A root 3 and AB is 2A. A and A goes, here comes under root of 3. So sine 60 is under root of 3. Now cos 60, curly black here, base by hypotenuse. And that means base. What is the base here? BD. And what is the hypotenuse? AB. Substitute the values. BD is A and AB is 2A. A and A goes, here remains 1 by 2. Now tan 60. Tan is the ratio of perpendicular by base. So what is the perpendicular here? Perpendicular is again AD and base is BD. And that means AD is A root 3 and BD is A. AA goes, here remains root 3. Now reciprocal of sine. Reciprocal of sine is cosec 60. Cosec 60 is if sine 60 is perpendicular by hypotenuse, then cosec is hypotenuse by perpendicular. And that is, what is the hypotenuse? AB. And what is the perpendicular? AD. Substitute the values, 2a by AD, that means A root 3. AA goes, here remains 2 by root 3. Then comes the reciprocal of cos, and that is sec 60. And sec 60 is the reciprocal of cos, and that means hypotenuse by base. Hypotenuse is AB and base is BD. And that gives me AB is 2A, as per the figure. AB is 2A and BD is A. AA goes, here comes 2. Then comes the reciprocal of tan, and reciprocal of tan is cot. And that means base by perpendicular. If tan is perpendicular by base, then its reciprocal is base by perpendicular, and that is BD by AD. And that gives me BD is A and AD is root 3. AA goes, here comes 1 by under root of 3. So these are the trigonometric ratios of angle 60 degree.